Hi there, folks. Root Beer here with question number 3 on our most recent Euclid, the 2009 Euclid paper. So we've got two parts here, light bulb and written, A and B. And what have we got for A? In the diagram, AB equals AC equals AD. So I guess A could be the center of a circle. And CAE is a straight line segment that is perpendicular to BD, which is why we have this nice little right angle here. What is the measure of angle CDB? Okay, we want angles here. CDB. So, what could we do here? So AB equals AC equals AD. Oh, equals BD. So that one's also the same. Okay. Then I guess we have an equilateral triangle. Then we've got some isosceles triangles off on the side here. Let's copy ourselves a picture into our notebook. Well, that doesn't even look very equilateral. What is with me? I can't seem to draw straight lines this video. Draw the equilateral triangle first. There we go. That's at least a little better. So there's A, there's B, D. Extend this down, we get E. But we have a nice little 1, 2, 3, 4. So we know that ABD is equilateral. So that puts 60-degree angles here. So if I knew what little bit was left over, maybe make it blue. If I knew this little bit over here, then we'd finally get to CDB, which is what we're looking for. Okay. Well, if I want that little blue angle, just chase it around the diagram. Since ACD is isosceles, we'll get that same angle up here. And what else can we say? So I'd probably say something like ACD is isosceles. So if I knew this angle here, I'd be all set. Well, we've got a straight line segment here, 90 degrees here, so this angle plus the other angle is going to be 180, but, let's use color. This orange angle here is plus 90 plus 60, it has to be 180 because we've got a nice little triangle there. So it must be 30, 60, 90 triangle. So what can we say? Angle DAE equals 180 degrees minus angle DEA minus angle ADE. And this is going to be 30 degrees. So we got a nice little 30 degrees here. So angle DAC is 180 degrees minus our orange angle. So it's going to be 150 degrees. So angle DAE. So this will end up being 150 degrees. And so twice, because it's isosceles, twice angle CDA plus 150 degrees must be equal to 180 degrees. So angle CDA must be 15 degrees. Subtract them, you got 30 degrees, divide by 2, 15 degrees. So the angle we're looking for, CDB, is 60 degrees plus 15 degrees. Our sort of red angle plus our blue angle. So we're going to get a final answer of 75 degrees. And so we'd put that in the little box that they provide us. But there's my explanation, just in case I made a calculation error. I can at least get some part marks, I hope. Okay. So, 3b, we're going to have to write up a bit more. In rectangle ABCD, F is on diagonal BD, so that AF is perpendicular to BD. Also, BC is 30 and CD is 40. Well, it's a rectangle, so that's going to tell me this is 50, because it's a 3, 4, 5 Pythagorean triple, although we will write that out if I need to use that fact. And AF is X, we just want the value of X. Okay. So, I'm not seeing where that 50 is going to help me right now, but that doesn't mean it's not going to help me. Let's draw a picture here. Now, F was chosen so we get a right angle, right? AF is perpendicular to BD. Okay. Then we get a nice little right angle here. 30. 40. And I do know it's 50, but I don't know if I necessarily need that right now. It's a 3, 4, 5 triangle. Now, I have a couple other right-angled triangles here. AFD, BFA, and BCD. So they're all right-angled triangles, but are they arbitrary? So the dot and the purple dot and the purple check must add up to 90 degrees, but in each corner we have 90 degrees, so this has got to be a dot, and this has got to be a check, and so this is going to have to be a dot, and this is going to have to be a check, so that all works out, and it turns out, I might say something like, we can see, and I would just have a clearly labeled picture right next to this statement, but we can see, we've got some similar triangles here. Triangle AFD is similar to, make sure you get the order of the letters right. So I went from the one with the dot to the perpendicular first. So BFA, and it's similar to the one with the dot. So DCB. Okay. Now, BCD is a 30, 40, 50 is a 3, 4, 5 triangle. So we could use that, I guess. So all sides for these triangles. Well, let's say this. Let's say this, because we actually do get marks for writing things up. Let's say by Pythagoras, or by Pythagoras' theorem, whatever you want to say, we can see that BD is going to be BD squared is equal to B squared plus CD squared, BC squared plus CD squared, which is 30 squared plus 40 squared, which is equal to 50 squared. So BD equals 50. So all three triangles have sides in the ratio 3, 4, 5. Okay, how does that help us figure out the x? Well, I think there's a couple things we could do. We could say that, if this length here is 3t, then x has got to be 4t. But then we'll get divide that by 3 and multiply it by 4, and we'll get BF, and we could add those up and get 50 and get t from there. That's certainly one thing to do. Although we know BA and we know AD because this is a rectangle. So I guess that's probably a faster way to do it. So But, I mean, not that the other ratio way is wrong. I just think this will probably be a bit more elegant. AD is equal to BC is equal to 30. So AF over AD has the same ratio. So first two, and then first and last, has the same ratio as first two over first and last. So it's going to be x over 30 is the same as 40 over 50, and so I'm going to get x is 1200 over 50, and that's going to, zeros cancel out, 120 over 5. 120 is 5 factorial, divided by 5 is 4 factorial, so 24. Just managed to squeeze it in. Didn't have to flip the page or anything like that. But there we go, 24. And all the key features are there. We've got similar triangle. We figure out some of the lengths. And, you know, you could have done that ratio T step, but I think this is a little faster. You might want to mention AD equals BC because it's a rectangle. I've got the ratios of the sides if I wanted to use that. But ultimately, this equation I think is probably what you really need. And you get 24 from that. Okay. So that's question number 3. Up next, quite naturally, question number 4. I will see you for that in the next video.